with another function that was the decorator and runs that. So here we have one type of macro, and that is actually we have two macros here. So the print line should actually be print line exclamation mark. There's a bit of a bug here, but print line is actually a macro in Rust. It doesn't actually it doesn't just to print line, just a run a function. It actually wraps it with a bunch of other code, takes in your string, and then uses that to print out whatever you put in there. Similarly, up here, this hash derived debug, that is also macro. It's a predefined macro in Rust, and basically it takes in the whole struct. So it doesn't just take in the next line or whatever you give it to that debug. It takes in that whole next struct and uses that to write wrap some code around it at compile time that is then run later on. So with this, we're able to do a lot more than just to replace certain pieces of code with other code. We can wrap whole structs, whole classes with new pieces of information. And yeah, now we'll move on to the borrow checker. This is the big selling point of Rust. Why people like Rust so much. Kind of the one of the things that makes it so tricky to use as well. So the borrow checker, it's the way that Rust handles memory uniquely. So other languages either have you handle memory yourself. So C, C++, you guys use things like malloc or new, delete, things like that. You have to explicitly say, I'm going to use this memory from the heap, and then say, I'm going to free this memory from the heap because I no longer need it. That's great because you only take what you need and give back once you're done with it explicitly. But you have to do it all yourself, and that can get really annoying or be really buggy. It's tricky to get it right every time. So the other approach that languages use is a garbage collector. So this is where you say, I want this memory, I want all these variables, and then the language says, okay, you don't need this anymore, I don't think, so I'm going to garbage collect it for you and put it away so now someone else can use this memory. This is like languages like JavaScript, Go, they all use a garbage collector. So if you declare a variable, you don't need to say, I'm going to free this variable. You just it goes out of scope, and then you can use the memory again for a new variable. What Rust does differently is it uses the borrow checker. So with the borrow checker, variables own certain memory, and this lives for some amount of time. The time isn't like literal time, but it's some amount of lines in program, perhaps, some piece of code, so some scope within brackets, things like that. And then once that memory is used, the lifetime ends of the memory. So once the memory is used, once it's moved somewhere else and it goes out of scope, then the memory is now free to use for other variables. What this means is that if we move our memory anywhere, it is now no longer ours. So we can no longer use that. It goes into the function that took the memory. However, what we can do is we can say this function will only borrow that memory, but it's not going to actually use the whole thing or modify it too much. It just needs to borrow the value. That's one way to work with this. We can also just copy data to new memory and say, here's a copy, and you can work with the copy. We want to keep the original. Or we can use things like manual lifetimes. That's a bit more complex, so we won't be worrying too much about that today, but that's another way to work with the borrow checker. So for example, to get a bit of feel of the borrow checker, we have a variable here, name, which is a string Rust. Name length 1, usually 2. Let's say, for example, if you had a function called find length of and name. If we didn't want to use name anymore, we can just move it into find length of, and then find length of now has access to name, and we no longer have access to name. We can no longer use it. It goes out of scope once that function finishes, and we now have the length of it through name length 1, but we don't have access to name anymore. What else? The other thing we can do is we can have find length of borrow that name. So we use ampersand before the variable name, and now find length of will simply borrow the variable. It'll have access to the variable, but it won't be owning the variable. So we can still use name after this for the next lines and everything, but we still have access to it, and then they also have access to it, things like that. What's up? So you're saying if we clone it or if we borrow it? So if we clone a mutable variable, actually, that's a good question. I'm not too sure if the new version is mutable. I would assume it is mutable because the original is. So yeah, in that case, I assume it would be mutable. If we borrow as well, I think borrow is not mutable. Actually, if you still need to declare it mutable, I think it is mutable. By default, it's not mutable. And then if you move it somewhere, it's a semantics of the original variable. So if it was mutable, then you can mutate the moved version. Otherwise, you can't. Yeah. Okay. Oh, okay. Right. So if we change, oh, so if you borrow a variable, if we change it, then it will change the original. Because we simply have a reference to it in the function, so it will change the original. If you clone it and modify the clone, then it won't change the original. Because it's a completely separate piece of data. So yeah, like I said, clone, the third one, if we clone it, we pass a completely separate piece of data that contains exactly data, but is identical data, but a different piece of memory. So it does not change anything. Yeah.
When does it read a name? Like it's allocated on the stack, right?
Right. So actually, that would be freed at the end of find length of, unless find length of calls something else as well and moves it somewhere else. So find length of now gets control of that memory. It can choose to do what it will with that, but once find length of finishes, the memory is gone.
And if it's like heap allocated, does that have to manage deleting that, or is that just like a C?
Yeah, so the board check will do that. Yeah. So if this was a string, the string class is actually allocated on the heap. And so with that, the memory would be moved into the function, and then yeah, heap it would be stored off the heap once find length finishes. Yeah. Any other questions? Yeah.
When and how is the GC worth it?
So what's that?
When and how is the manual GC worth it? Like I bother with the dollar factor and any type of GC, manual GC.
Right. Okay, so yeah, garbage collection is probably better if
embedded.
Probably not embedded. So embedded, I think you might want things like Rust or C++, where you have very predictable memory accesses, and garbage collection won't just happen at random times. In embedded applications, you might have a system where if the garbage collection starts running at a certain time, you could lose a lot of really important information. Something fatal could happen to the system. So you really don't want unpredictable garbage collection at certain times. You want to be able to know when memory is being allocated and destroyed, and you don't want pieces of code running when you don't expect them to. So for those cases, you probably don't want garbage collection. But for application systems, for applications, for like web applications, I'm thinking desktop applications, having garbage collection isn't the worst thing, honestly, because it's probably not going to cause anything too fatal. Yeah.
So does DC hold the entire program execution?
Yeah, unless I'm not sure if there's any languages where it runs on a separate thread, but yeah, if you're seeing single threaded, it'll hold the program, run the garbage collection, and then continue the program. Yeah. Any other questions? Yeah.
You said in the base function call that name gets moved.
Yeah.
So does that mean in the next two function calls that you can't access name anymore? Like,
yeah. So this code would actually not compile. It's kind of just an example. So like, if the second line didn't exist, the third and fourth line would compile. But yeah, the second line means that name, we can no longer access it in any future line of code. Yeah. Any other questions? Okay, sounds good. We'll move on to cargo. So this is just Rust Package Manager. If you guys use things like npm, pip, it basically allows you to add packages, but also helps you compile, run your projects, build them, and package them back into Cargo Online. So some important commands would be cargo new, which creates a new project. We won't be doing that today because we have starter code. Cargo run, which runs the current project, and then cargo build, which compiles the project to a binary that we can run on any kind of system based on what we compile. Yes, yeah. All our code is going to be in source/folder. That's how Cargo builds your code. You run Cargo new. So yeah, we're now going to parsing. So that's command line parsing with clap. I'll talk a little about clap, but yeah, parsing in Rust is great. It's one of the reasons why Rust is so used for command line applications. Now, what you guys can do is fork and clone the repository. That's the starter code. So that's also in the hack pack. But anyways, yeah, that's https://github.com/arnoldgupta03/htn-cli-workshop. What you want to do is you want to fork the repository first. So you can hit the fork button there in the top right. The fork is your account, so now you have a copy of the repository for yourself. It's on your own account. And yeah, so you can fork that there. If you don't have an account, don't worry about it too much. You can just simply clone it. So there should be a button, a big green button that says code. You can click on the button. It should open up something like that there. and click on the HTTPS if that's not already selected, and you can copy that link. If you're using GitHub Desktop, you can simply paste it into a button. I think it's import from repository. I paste the link, and then it should open the repository there for you in your computer. Otherwise, what you can do if you're using the command line, you can type git clone, paste the repository, and it should clone the repository in that directory, wherever your terminal is at that time. Any questions on that? Okay. So I'll continue. While you guys do that, I'll start talking a bit about clap. So clap is Rust command line argument parser. It just stands for that. It makes it really, really easy to parse command line arguments. Parsing command line arguments is annoying sometimes because you don't know if something's an integer or a string or some kind of complicated list. With Rust, that's really easy because of clap. It does things like add a help menu or add about information and version info to your command line application with really simple macros. You don't need to build out a full string of like, okay, this is this command, this is documentation for it. This is a command, this is documentation for it. You just define your arguments in Rust as a structure, and clap takes care of all that for you really, really well. It also defines structs. So yeah, you just define structs that define the args, and you use macros to specify the options for the args arguments. For example, if you want something to have a short name, long name, for example, if you have an application, we're making a password manager. So if we have an operation, they can either pass -o or they can pass dash operation. And that is based on a option that we pass to clap, being short name and long name. There's also defaults. We can say that a value is an enum, so Rust knows that can only accept a certain value, a certain range of values. We can make arguments optional, and that's all just done through Rust though. We don't need to say this argument is optional. We just tell Rust this variable is optional, and then the argument becomes optional on its own because of that. And yeah, like I said earlier, we can give options to arguments. And yeah, let's start coding. Anyone need more time to clone the repository? Okay, sounds good. We'll start coding then. So this is what your code should look like. So you should have a file here called, or folder here called source. In that, it should have main.rs. If you don't have target, that's fine. You don't need to worry about that too much. It should have cargo log, cargo toml. Those are two important ones for our project. And then you should have a store.json file here as well in the source folder. That's not a Rust file, that's just something we're using for our application to store our passwords. All right, and yeah, so just open up main.rs, and that way we can get started with the coding part of this workshop. Give me a second for that. Yeah. All right, so let's start exploring this code a little bit. So at the top here, use and then those names, that's basically just imports. So if you use import statements like from something import in Python or import something from something in JavaScript. We're just importing packages here. The starting from line 9, this is where our code starts. So we have this here, which is a macro again. We're using a macro that Rust already has for, and some of these are coming from clap as well. So value enum is coming from clap. Clone and debug are coming from Rust, standard Rust. So it just gives us the ability to clone something and to debug something. Debug basically makes it easy to print in print in print statements. And we have an operation there. So the three operations that we worry about today are generate, insert, get. So get a password, give it a name, insert password given a name and a password to insert, and then generate a password based on a name that they gave. We just generate a password and store it for them. So on the next part here, we're going to work on two different interfaces. Like I talked about earlier, we are also going to talk about a terminal user interface, so TUI. And so yeah, that's just our T interface enum there for that. And then line 23 here, this is our arguments. So here we're actually defining our arguments for clap. We have an about section here, so we're saying a simple password manager. You guys can change that if you guys want for your own password managers. And then a long about, we don't want a long about, we just want simple password manager. It's not a super complicated application, but if you guys had one, you could add it there and it would write it for you in the help menu. And yeah, we just find a struct here. Our struct has these options. So short, long, value, enum. Default value would be default here for the name. And then, yeah, short, long, like I said earlier, short name, long name for -o versus -- operation. And here, you can see, Rust has an option type. So this is either values to some or none. Some contains a value, and then none contains no value. And with Rust, we can just write option and then some kind of variable type, and we can use the option right there. Any questions about the class stuff? No, okay. Okay. So, actually, good question. I will just show you in the help menu. So here we have we're in the project. Just ignore the previous lines there. So we cargo run, and if we do, that should help. So yeah, to actually run our CLI, to pass arguments, we need to run cargo run and then -- Anything after the -- is passed with arguments to our CLI. But yeah, so I'm running -- help, which is show our help menu. Compile, show some errors because we still need to write some more code. But yeah, if you see here, I'll zoom in that in a bit. We have a syntax here for our options, so what things we can pass in. And for that, we have operation, so that's -o and then dash operation. We have -name and dash name. So short long there is that -o is the short, dash operation is long. Does that help? Okay, perfect. So yeah, that's what that means there for short and long. Okay. Anyways, we'll continue with our function main. So here we are parsing our arguments. So with Cloud, we don't need to worry about, okay, we want to parse this argument, this argument, this argument. We say args parse, and it parses everything for us. Then we have, so like I said earlier, we're storing everything in our stored.json file, just to make it easy. JSON is kind of pretty widely used. It's not the most efficient, but it's easy. And then we'll be opening file and then reading it into some buffer reader. Basically opens the file, and we open the file here, and then we just read it. Now, what we want to do is we have our match statement here. So based on the operation that they gave us, which is an enum, so we only need to worry about, we need to worry about either some or none. So they could have not passed in an operation. We made that an option so that we can use terminal UI. So we'll talk about a bit about that later. But if they do pass an operation, so in the sum case, the operation can be generate, insert, or get. And so we need to, based on what they pass in, we need to do write the code. So let's get started with writing the code for the get case. So we have a reader here that has everything for the password stored, and now we want to get the password. So what we can do here is inside these brackets, inside these curly braces for get, we're going to write match and store dot contains key. So I want to check, does our store actually contain the key we're looking for? We're looking for a specific name in our password manager. Does the store contain it? Actually, we don't have a store yet, I realized. I've Copilot on, my bad. Sorry about that. Anyways, we're gonna ignore that. We do need a store first. So yeah, we have a reader here. After this, we need to make a store. So our store is going to store our JSON in key value format, so we can reference it really easily. We're going to make let mute store. We want to mutate it later on, right? Because if we're adding passwords to our store, we might want to mutate that later on. So we let mute store as a string, comma value. Can I turn off Copilot? Okay, I'm turn off Copilot. Stable completion. Okay. Perfect. Okay. All right. String value there, and we're gonna match it to. Oh, it did not stop.
Now it's stopping. It took a while to stop, I suppose.
Okay. Okay. Anyways, just ignore Copilot. Just ignore that. So we're gonna use a JSON library to get to work with JSON. So JSON is the best library for JSON for Rust. Makes it really easy to work with JSON for Rust. And we're gonna match using the JSON library. I'm ready to get our JSON from a reader. So like I said earlier, we had a reader. And from a reader, we're gonna get our JSON file. It's going to parse it for us really nicely. And we're going to have OK be JSON. So we have JSON, and we're going to return the JSON. After the arrow is basically what we returned. So we get the JSON, we can OK, we have JSON, and we return the JSON to store. So now store contains our JSON. It's possible this will fail. So it's possible this will cause an error. And in that case, we want to return, we don't want to return anything. We want to say, we found an error. We have no idea what to do. Something is really, really wrong. And what we're going to do is we're going to say the error is going to be panic. So panic here is a macro. And so if anything has an exclamation mark after it, it's a really good chance it's a macro in Rust. And so it's going to expand whatever you put inside it into the, it's going to put it into the terminal or whoever called it, and then stop the program. So if something is wrong, we cannot continue, panic. We're going to say couldn't parse store file JSON. And then we're going to put brackets here, and then y. The brackets there are basically, we have something we want to put in here that's a variable. We can put options inside the brackets. So we can put like, I think, colon question mark does a vector. So it prints out a whole vector. There's other options you can put in there as well. I'm not sure exactly what the syntax is there. But we can put different options there. Here, we don't want to do anything special with this. We just write the y directly there. And we're going to have a comment here. So yeah, as a note, Rust uses semicolons. So every statement needs to end with a semicolon. That's kind of what Rust is. Follows from the C tradition. Anyways, so we now have a store. And using our store, we now get things from our store for the password range. So we're going to go back to here. It says some operation get. All right. So here we are going to want to get the passwords. Now we have access to store, and we can check if our store contains the key that we're looking for, which is a name. So we're going to go match store dot contains key, and it's going to contain args.name. So our name is part of our arguments that they pass in, and we're going to check, is this false or is this true? So if it's false, this means we found no password for the password they passed in, and we should tell the user, okay, you passed in a password that doesn't exist. Well, we don't need panic. It's not a big deal. We just didn't find a password that they wanted. So we'll tell them, hey, no password for the name you look for. So false means print line, no password for, and then the brackets. And we're going to pass args.name after that. Actually, we can just have a comma here. So yeah, match cases and with commas, not semicolons. So I'll have a comma there. You can see here, it's giving me an error. And that's because we haven't covered the true case. So Rust will not compile if you don't have all the cases covered. So now we're going to cover the true case after this. So our true case, in this case, we have the password in our store. So let's just return the password now. So true, this means we're going to match, match, ampersand store. So we're going to borrow our store. We don't want to modify it. We still might want to use our store later on. So we're going to borrow our store and borrow arg's name. And with that, we're going to so arg's name could be a series of values. Standard JSON makes it really easy to parse JSON, but it also has a bunch of different types for what values can be, because JSON values can be a bunch of different things. It could be numbers, strings, things like that. It could be nothing as well. So null is a potential value. So in case our value is null for some reason, we want to handle that case. In that case, we again have no password. So we're going to tell our user print line, no password for you. No password for curly braces, args.name. All right. And if we can also not have a semicolon at the end of the statement. That basically means this is the end. This is what's going to return. So if at the end of the function you want to return x, if you put x at the last statement with no semicolon, it'll return x. You don't need to write return. That's another really cool thing about Rust. It's a feature of other languages as well. But yeah, that's one thing there. So we don't need semicolon there. I think you can have it, but you don't need it. And then we'll also have a string value. So our value could be a string. If value is a string, then we want to tell them, hey, we found your password. So print line and then password for that person. that name is, and then brackets there again. So first you want to say password, misspelled there, I'll fix that later, but our password there is args.name, and then the actual password itself is the S. So value string here, that S in there is the value, that string value that we are looking for. So we have a store, we matched it with a name, we got a value back. This value was a string, and because it's a string, we know what string it was. We can use that string to print back to the user. And there we have it. Now there's a bunch of other type of values here, so we also need to worry about those. So like the question asked earlier, what do we do about the other cases if we don't want to find them all directly? We need to use the underscore, so underscore, arrow, and then panic. We had an error here. Someone passed a bad name, so bad name passed. We do not have his password, or the password is passed in and our JSON contains a number for some reason, something like that. We have a really weird case here. We need to stop and we need to look at what's going on here. All right. Spelling there. Any questions though for this code? Yep, so. Value is an enum. So value : null is basically the enum value. We want the null value of it. I guess that's a little circular there. For example, here, so we have operation : insert. So remember we defined the enum operation. Insert is one of the types of operations. So we have operation : insert. Similarly, the people at Saturday have defined this enum value, and null is a specific type of value. Yeah.
What's the difference between : and dot?
Dot is for structs, things like that, classes where you have a specific field. For enums, it's not really like it's not a field, right? It's a type of, it's something of the enum. It can only be one of them, where you can have a get and an insert in a operation. So that's kind of the semantics of, that's how I understand it personally. Yeah. Yep. This one here? Here. Yes. It is not. It is optional there, because we have curly braces. So the math statement knows, okay, we have these curly braces control this piece of this case. So we don't need to worry about that. The comma is more for like if you have one line. That was a good catch. Thank you for that though.
In this case, you wouldn't need the curlies, right? You can one line.
I put it in line. Yeah, I could just have one print line there, comma, and be done with that. Yeah, that is definitely an option here. Any other questions for this piece of code? Okay, we have one more case we need to worry about here. Actually, no, we don't. No, never mind. We're good. We are good here. So now our application should work. Forget. We can test that out. You guys go to your terminal. So you guys are all saved. I did not save. Okay. So save your program, and then you can go to, I use a VS Code terminal, or you can use a regular terminal, whatever that is for you, Bash, Z Shell, PowerShell, what I'm using here, any kind of terminal, because you already have Rust installed, hopefully. And what you can do is you can pass it, so you can go run cargo run, and then dash dash. What we want to do here is we want to get a password. If we check our store file, so in the VS Code, there it is, VS Code, our store.json, it has, okay, sorry about that. The current change, okay. So it has Facebook here, Facebook, a password for Facebook, and we want to use that password. So we're gonna get the password just to test our application. So let's we're gonna do -o, our -o is get, and our -n there is name. So -n is gonna be Facebook. What it's gonna do is gonna run the operation get, and it's gonna run with the name Facebook. Password and insert and interface are both gonna be null, do not exist, and then we're not running help, so that doesn't really exist here. So if we run this, we should get our, okay, do not compile. Okay, yes, so I'm missing some imports. So Rust imports are a bit finicky sometimes. Sometimes they don't load in firstly, but what you want to do is you want to import from started.json. So what you're doing is use Saturday JSON. This should already be in your project, so you don't worry about installing it to project. And we do : we want map and value. The map that we made earlier was a Saturday JSON map that we were referencing, and then we want value because we're using the value enum. So yeah, let's try that out now. Oh, okay, I'm still missing something. Unuseful undeclared type value. Oh, did I not save? I did not save. Okay. Remember to save your code. Okay. And you build it. Okay. All right. So now it returns password for Facebook and the password for Facebook. So that's what we want. We're gonna get password now. If we run it with something else, so if I just literally run it with something, we don't have something in there. So no password for something is what we want to get. Yeah. So now we have get working. Any questions for that? Okay, so we'll move on to the insert and generate. So if we think about insert and generate, it's kind of similar, right? If we insert a password or generate a password, either we have a password and we want to insert it into our store and save it. So what we can do is we can make a function for that just takes in our password and then adds it to the store. For that, what we're going to do is we want to use some of this information from earlier. We already have a store here. We already have a reader. Why don't we already use some of that information and make a function using that? The thing about Rust is you can't define if you define a function inside a function, you can't use these variables. So what we're going to be doing is we're going to be using something called we're going to be using a function where it just takes in a value and then creates a function based on this, but we can use these other values because that function is actually just a variable. If you use something like const something equals brackets arrow and then other brackets in JavaScript, that kind of function, it's kind of something similar where the function is just a variable. So we can run that function by running the variable. So here, we're going to be starting by doing let mute insert password. So insert password is going to be the name of our function. And in these pipes is where we're going to put our parameters. Our parameter here is just one password, the one param, and we want to insert some string. So we want to know what string we need to insert. And so we're going to put that in between our pipes. And then I'll put, okay, it's curly braces here. I'll close the sidebar so you guys can see better. Okay. And the first thing we want to do is we want to insert our new password into our store. So store.insert, and yeah, we're going to clone our variable. Clone. All right, we're going to clone it, and this way we don't lose our args name. We might want to use it later, so we just clone it. Because store actually needs the whole value. We can't just have it borrow because it needs to insert our value into a map. What happened there? Okay. Anyways, our store needs to take the whole value, so we need to clone it. Like you see there, we have cloned it. And then we need to tell it what kind of value it is. So, or sorry, then we need to have the actual password we need to insert. So we're gonna make a Saturday JSON value that holds this password. Password is gonna be a string, so we're gonna make Saturday JSON value string, kind of a long line, but with that we can insert a password. Search Saturday, like it says there, Saturday JSON value string to insert, and with that we now have inserted an element into our store. So we inserted the key name and the value with to insert. Right. Now we want to create a new file. So what we're going to be doing here is kind of inefficient. We're going to be taking a store from a JSON file and then rewriting the whole file. It's a little inefficient, but it's kind of just the easy way to work with JSON with Saturday. Otherwise, writing back to files is a little finicky. So we're just going to be doing this instead. So let mute, and we're going to create a new file. We're just going to match file create. And the file's path is at path. So path is a variable we defined earlier. We can use it in here because we're not making a new function here. We can just use, sorry, okay. We can just use the path variable from earlier. And our match cases here are going to be OK and error. So if in the OK case, we want to return the file, and then error case is going to be Y. I realized I didn't talk really about what the OK and error here is. Basically, Rust has a type called result. Result can either be okay or error. So instead of things like exceptions, for example, in JavaScript or C++, they have exceptions. In Rust, we have return errors as values. So you return a value for an error. A function returns a value. If a function could return an error, you return a result. The result can either be okay and contain the value of the function's return, or it can return the error itself. And then you can choose what to do with the error once you get the error. It moves basically you can't lose track of errors this way. In things like JavaScript, C++, if you have try catch and you if you don't have a try catch and you run a function, it'll just break your entire program. With Rust, you can ignore an error, but that error is always there. So you know which functions are going to return errors. You don't know if the function is going to return an error or not, like you might have with JavaScript, C++. So here, we know that file create could return an error. So in the case it returns an error, we're going to say we couldn't update the store file. And yeah, like there, we're going to write y. Right. And a semicolon here. And then now we're going to write our file out. So we're going to match new file, not colon, dot write all. So I'm going to write all our values from our store. So value object, we're going to object that contains our store. Sort of clone, because we still want to use our store later on. We don't want to lose track of our store. And using this object that we created from our store, we're gonna turn to a string, and then turn into bytes. Bytes is just so that Rust, Saturday can write it out to a file. And the two cases here are, okay, we got a file, so we return the file. Or again, we panicked. So I'll just copy this line here, down here. And in this case, it's not that we couldn't update it, it's just that we couldn't write to a store file. So we couldn't write to a store file. All right. And this is a variable, remember, our function. So we need to end with a semicolon. All right, perfect. So here we now have an insert password function. Any questions on that? Okay, sounds good. So let's get into actually writing the generate insert here. So for generate case, we want to generate some kind of password. So to do that, we're gonna use rand. Rand is the Rust random library. So we're gonna do let to insert equals rand. Thread RNG is basically using the random number generation thread. We're gonna use a sample iteration. So we're gonna a number of samples from our random number generator. Put that there. It's not gonna be distro here. It's gonna be actually ampersand alphanumeric. So we're gonna borrow the alphanumeric distribution. We want either numbers or letters. So we're gonna sample of numbers and letters. How many do we want? We want, let's say 16. I think 16 is a pretty good length for a password nowadays. If we take 16 random digits, you can change the number, make something else if you want. And we want to take every single value and get a character from it. Not wrong, that's from. Oh, okay, sorry about that. All right. And we can cut all these values into a nice vector. And if I save that, it should, oh, then okay.
Just write the data over line. Oh yeah, we're
Yeah.
right now.
Yeah. All right, there. So hopefully you guys can see that there. So sample, take 16, map it into characters, and then collect them all together. And then we want to call insert password on this password. So insert password to insert. And this is going to insert our password based on the function we defined earlier. Makes it really easy based on password we generate with that random number generation there on line 73. Insert can be really similar. So here, the only difference is we just have a password to insert. So we took that in from clap, and we're just going to insert that. So we have let to insert, and we're going to let that be match our password to insert. Remember this earlier, this could be either some or none, but it was an optional. So some password, and this is going to be password. Okay. And then in none case, we did not get a password insert, but they wanted to insert password. So the user messed up here. This is something they messed up. So we'll say print line, please pass password to insert. To insert. And we're gonna return okay. Actually, no, we're gonna return okay. Yeah. So that's password insert. And given this, we're going to now insert a password. So insert password to insert. Similar to earlier. Okay, I think we have an issue. I think we do need for return. Okay. So we're going to return okay here because our in this case we want to stop doing anything. We don't want to actually do the next line, which is insert password. We want to stop doing everything at all overall. So we're going to return okay. Okay. Function. Oh yeah. Function main does not return our result here. Okay, never mind. Okay. So we're just gonna return. Return okay will be for when we do the terminal UI, which hopefully we'll get to. If we don't get to it directly, all the code is in the solution branch of their starter code, so be able to check that there. Regardless, I'll talk over the terminal UI even if we're not able to get to it in the code. So yeah, any questions on the generator insert? Yeah, perfect. All right, so let's get started on trying it out. So we're gonna try generating a password. So our operation here is going to be generate. Not in Facebook, let's generate a password for Google. And similar here, you just operation generate, name Google. We don't need to send a password or insert. We don't need to send a UI. By default, it's going to be CLI. So I'm going to enter error. Okay. Okay. So some error with the new file there. Let's check what that is. So we're going back to our here. Okay, so our file for some reason does not have a must have copied something wrong. Anyways, okay, we are running a little low on time, so I won't debug this here. Yeah, like I said, the code is in the solution branch. That code definitely works. So yeah, feel free to match it against there. Also, if you have any questions, maybe after the workshop, and we can talk about it. Yeah.
The Rust compiler told you to use the write instead of write all. Was that right?
I don't think so. I think write all is the best case here because we are using a store object, and we want to write all the bytes all at once. Yeah, so write all should be working here. Yeah, it's not an issue with that, but some other issues coming up here. I'm not sure why. I think it has to maybe with the file. Might be some syntax issue error there.
Maybe package updated, but you don't have a log file, right?
Maybe. Yeah. Maybe the package. We do have lock here, so shouldn't be a Rust version issue. I don't know. Anyways, if you guys since we're running low time, I'll just say what we can talk about later. And yeah, like I said, code is in the solution branch, so definitely try that out. If nothing else works, or you could use this as an opportunity to try debugging Rust for the first time. Anyways, hopefully maybe it works on your guys' machines, maybe it doesn't work on mine. But yeah, I'll get started talking a bit about terminal UI. So this is about making our CLI prettier. Terminal UIs are really great because CLI applications are just not suited to every single use case. They're really great for certain cases, things like Git, that's a really helpful CLI. But sometimes you want a bit more of a UI, you need a bit more of a UI. So you might be saying, like, why don't you do desktop application? They're great, but what if you're on a server? You can't really have a desktop application there, right? You can't open up, you might not have a desktop environment there. What if you're a heavy console user? You just really want a terminal UI application or something. Or what if you're just constantly navigating between directories and you need to open up an application in every single directory? Opening up in a desktop application could be kind of tedious. So terminal UIs can fix this for us. It'll give us a nice, pretty terminal UI for our application. And some examples, Vim, we're going to use that. Really popular terminal UI application. Wouldn't be possible as a CLI, right? You can't just say, I want to change this character over this on this line, this column. Not really possible. A more popular one, Vite.js. If you guys run Vite create, it'll give you a UI like this, where you can select it from where you can go up and down, up and down. This is kind of a CLI, but also kind of a terminal UI, right? Because it gives you a really good interface to be able to interact with the terminal that isn't just running commands through the command line. Yeah, so those are really good examples of terminal UIs. So yeah, steps to running a terminal UI. What we would have used here was Ratatouille. That's a Rust package for running a terminal UI in terminal UI. The backend here would be Crossterm. So Crossterm is actually the backend for creating the terminal and managing it, and then Rust is creating and designing the UI of the terminal UI using Crossterm as backend. How does it work? The code here would basically be we initialize the terminal, then we tell standard out to use this terminal set. So we're going to say we have an alter terminal, switch to this terminal now. And so it switches to that terminal as an alter screen. We then render and handle some input on it. So we say we have a terminal now, we're on that screen, we're going to handle these inputs, and we're going to render this. What this would have looked like is what the code solution should do is it should create a terminal UI that displays all our passwords line by line. And that's the render, and then the handle input there will be quit. So we can't actually go back to our original screen unless we quit. And so we see if you hit Q, it should go back to the original screen, and that's the user input we want to handle there. And that's our quick condition. We want to turn off the alternate screen. What that's going to do is we're going to tell Ratatouille, hey, turn off the alternate screen. We're going to go back to our original screen. It's going to restore your terminal as it was earlier. So that's how terminal UIs work. Any questions on this? Okay, cool. All right, we're not going to add this just because of time, but in the solution branch, try that out. Quick note on encryption. So password manager, encryption is really helpful for that. Encryption has changed a lot over the years as standards have changed for encryption. They use things like RSA, different encryption schemes. Today, most use AES 256. It's a really strong encryption scheme, and that's why it's really popular. It's symmetric, so it uses the same key to encrypt and decrypt. We use something like RSA that's like asymmetric, where you have one key to encrypt, it's a public key, and then private key is used to decrypt it. So it's faster because it's symmetric, so you just have one key that does both, but it's a little less secure because if someone gets a key, they can decrypt it immediately. It uses something called a block cipher. So we have our data, we have our password, we divide it into blocks. So by divide into blocks before encrypting it, and then we encrypt each block separately. AES 256 uses a 256 byte block. And AES 256 is also considered quantum resistant. So it's really powerful, really secure. So we don't need to worry about, when quantum computers get really good, we don't need to worry about our password manager going down unless they find some algorithm for it. But currently it's considered quantum resistant, so we should be fine for the near future. With Rust, this is really easy to implement. We would use the AES GCM crate. It's been audited and found to be safe by a number of agencies. So it's definitely safe, definitely it's really fast at encrypting things. And we don't need to implement these algorithms manually. These algorithms to implement encryption are annoying and tough. We don't need to do any of that manually. We can simply use the AES GCM crate. It creates a lot of things for us. It'll create a key for us. It'll create a thing called a nonce for us, a salt. And we can use this to encrypt our passwords, potentially store this somewhere so we can decrypt them later on. But yeah, super, super fast at doing all this. But yeah, anyways, that's all for the workshop today. Like we didn't produce the code, but yeah, try it out in the solution branch. And yeah, any questions? Yeah.
So that encryption method,
you
just said, can you use it for SSH?
I don't think it's supported in SSH. I don't see why you wouldn't be able to, but I don't think it's supported. Yeah. Any other questions? Yeah. Okay, good question. There are a lot of Rust books. They're not actual books, but they're websites online where they'll tell you how to make different projects in Rust. There actually is one book just called the Rust book. It's not actually a book, it's online again. And it works you through making a couple different types of projects. You can understand Rust really well, work with the border checker, work with different features of Rust really easily. And then, yeah, like I said earlier, there's a ton of projects in Rust. If you look at any kind of project, there should be a Rust book for it. Just think like if you want to make like an emulator, make an OS, make a compiler, you can do that all with Rust. There are guides for that. So yeah, I recommend checking those out if you guys are looking for where to go with Rust for the future. Yeah.
How do you feel about the traits?
Traits. They are really cool, and I think really tricky to get your head around as a beginner. I think this is other languages too, if I'm not mistaken.
Yeah, it's the type classes from Haskell.
Right. Okay. Yeah. So yeah, trades. Yeah. If you guys are familiar, basically it allows you to. So if a class has a trait, it has a certain number of functions defined for it already, or it has an interface for it. So you can define those functions. If you give that class a trait. Yeah. So that's kind of how that works for yeah, Rust traits. They're really helpful, but yeah, they are kind of annoying to work with because if something doesn't have a trait, you need to give it that trait to be able to work with it for yeah for that specific use case.
Are optionals and the result trait.
I don't think they're traits. They're return types. They're not traits. They are yeah. There's types of enums pretty much. So result and optional are both enums, and then you return either some none, which are values, or okay error. Yeah. Any other questions? Okay, perfect.
If people have any other questions, please just go up and ask.
Yeah, I'm also on Slack, so yeah, feel free to reach out there.
Thank you so much.
Okay.